Welcome to the deep dive. We're jumping straight into the pretty complex world of data science today.
Yeah, it's a big one.
And you, our listener, you're probably navigating this field somehow, maybe as a practitioner, maybe hiring, or maybe you're just curious about what it all means.
Exactly. Our goal is really to cut through some of the noise.
Right. Deliver the core insights without getting too bogged down.
We've pulled together some really interesting articles. They look at data science from different angles, skills, workflows, career advice, ethics. Even the role of social science comes up.
Okay, so our mission then is to distill the key takeaways from all these different perspectives, give you practical ideas, maybe some new ways of thinking.
And keep it confidential, hopefully useful.
Let's do it.
Right.
So where do we start? What are the, fundamental skills? What makes a data scientist really effective?
That's the million-dollar question, isn't it? One article tackles this really directly. It tries to move past just listing things like stats or coding. It uses this idea of dimensionality reduction for skills, trying to find the core distinct abilities that don't overlap too much, the orthogonal skills they call them.
Orthogonal, right. So minimally overlapping, but highly informative dimensions of skill. Like instead of listing stats and ML separately, if they largely overlap in practice.
Precisely. Find the underlying fundamental competency. And interestingly, it even questions if coding itself should be one of those main dimensions.
Really? How so? Because coding seems so central.
Well, the argument is that coding ability should sort of naturally emerge from the other competencies. You need it to integrate with the tech stack, to make work reproducible, scalable.
Ah, okay. So it's a tool, a means to an end that you develop because you need to conduct analyses or build pipelines,
Yeah.
not necessarily the foundational skill itself.
That's the idea. It supports the other skills.
Yeah.
The article also makes a point of distinguishing data scientists from, say, data engineers or analysts.
Which is helpful because those lines can get blurry.
Very blurry sometimes. One person might wear multiple hats, but thinking of them as distinct roles helps clarify the core focus.
Got it.
And here's a really interesting bit from one source. It emphasizes team competency over individual mastery.
Oh, I like that. Takes the pressure off needing to be a unicorn who knows everything.
Exactly. It suggests that individual skill gaps are okay, even expected, as long as the team collectively has all the necessary bases covered.
So the whole is greater than the sum of its parts, basically.
Yeah.
The team needs the full skill set.
That's the argument. A robust capability depends on complementary skills.
Okay, so what are some of these core competencies the framework breaks down?
Right, it gets quite specific. First up is design analyses. This is crucial. It's about taking a business need, which is often kind of vague.
Often very vague, yeah.
Right, and translating that into a concrete technical plan. It includes thinking about milestones, even like stopping rules for the analysis. When is it good enough?
So planning up front, not just diving in, and thinking about potential problems.
Yes, explicitly. Anticipating competing explanations, figuring out the best way to evaluate results metrics, benchmarks, KPIs, all that planning stuff. Experiment design, sampling.
Thinking critically before writing a single line of code. Okay, what's next?
Then comes conduct analyses. This is probably the part most people picture. Exploring data, distributions, visualizations, feature engineering.
The hands-on data work.
Exactly. Building or applying the right algorithms, regression, classification, whatever fits the problem in the data. And, crucially, clearly documenting what you found.
Documentation is part of the analysis itself.
Yes, things like good visualizations, clear technical communication. If you can't explain it clearly, how solid is the analysis, really?
Good point.
Then there's incorporate analyses into pipelines. This is about making the analysis work within the broader tech infrastructure.
Okay, bridging the gap to engineering.
Right. Reading and writing data from databases, files, APIs, handling complex matching, filtering text patterns, timestamps, and ensuring it all plays nice with the engineering stack, like using version control, following coding standards.
This is where that coding skill becomes obviously necessary then.
Absolutely, it's essential here. But it serves the purpose of integrating the analysis.
Makes sense.
Next is incorporate pipelines into the business. This is more about the human side, understanding the real business needs before you start the tech work.
So requirements gathering, industry context.
Exactly. And navigating the organization, managing stakeholders, building relationships, plus packaging the technical work for different audiences,
Mhm.
especially non-technical ones. Communication is key.
So making sure the insights actually lead to action.
Precisely. It's about impact. And the final competency mentioned is build the profession.
Beyond just your own projects.
Yeah, contributing back, like going to meetups, contributing to open source, blogging, mentoring within the team, maybe even helping draft internal policies like interview guides.
Keeping the field moving forward, both inside and outside the company.
Right. It also briefly mentions competency levels, using that classic conscious competence model.
Ah, yeah. Unconscious incompetence, conscious incompetence.
Conscious competence, and finally, unconscious competence, where it's second nature. It's a useful way to think about skill growth.
Definitely.
And the key message is to use a skills rubric like this for development, for planning growth, not just for looking backward in performance reviews. Focus on delivering value.
So identifying areas like, I need to get better at understanding business needs, or I need experience with this specific technology.
Exactly. It's forward-looking.
Okay, that's a really comprehensive view of competency. Now, shifting gears a bit, another article talks about streamlining the workflow,
Yes, this one focuses on efficiency and reducing mental overhead. The idea is to codify repetitive tasks.
automating the boring stuff.
Pretty much. Cleaning data, making standard plots, things you do over and over. Automating them saves time, obviously, but also improves consistency.
Less chance of manual errors creeping in.
Right. The article uses this nice phrase, logical beauty, in workflow design, aiming to minimize the brain power spent on tasks that aren't the core problem-solving part.
Freeing up cognitive load. I like that.
Mm.
Are there principles for designing these workflows?
Yeah, it outlines a few key ones. First, define the purpose of the specific workflow clearly. What is it actually meant to achieve?
Okay, focus.
Then, identify the tasks proper to that purpose, the ones that actually prevent the workflow from failing, versus tasks that just make it, nicer or slightly easier.
Focus on the essentials.
Then there's that idea of orthogonality, again, keeping independent components separate. Don't tie things together unnecessarily.
Like how you get the data shouldn't be tangled up with how you visualize it if they're logically separate steps.
Exactly. And finally, aim for generality. Design components so they can be reused in different situations if possible.
Build reusable tools for yourself.
Right. It gives a simple example, automating plotting geolocation data. It breaks it down cleanly into, get the shapes, like country borders, get a map picture, and then put the shapes onto the picture.
Simple, but it illustrates breaking a task into logical, potentially reusable steps.
And the benefit isn't just saving time. The process of codifying forces you to really understand your workflow step by step. It can uncover hidden assumptions you were making.
Ah, that's interesting. The act of automating improves the process itself.
Often, yes. It can lead to better workflows and even just better coding habits overall.
Makes total sense. Okay, let's pivot again. Career navigation. This is always a big topic in data science. One source had some, let's say, practical, maybe even slightly contrarian advice.
Yeah, this piece was full of grounded wisdom, I thought. One big warning was about sideways promotions.
Sideways promotion.
Yeah, moves that might look like a step up, better title, maybe more money, but actually take you further from the work you really love, like moving into management if you actually love the hands-on analysis or coding.
Right, the classic dilemma, chasing the title versus job satisfaction.
Exactly. Understand what parts of the job actually make you happy day to day. Another interesting point was about not necessarily aiming to solve huge, world-changing problems right away.
Really? That seems counterintuitive for ambitious data scientists.
Well, the author talks about finding real satisfaction and, surprisingly, more opportunities for interesting R&D by focusing on well-defined, even seemingly smaller business problems first. They call it widget making.
Mastering a specific domain, getting really good at solving that problem, can build a foundation for bigger things later.
That's the idea. It provides stability and focus, which can paradoxically lead to more innovation. The article also really stresses finding companies that value individual contributors, ICs.
Meaning they have career tracks for senior technical people that don't force them into management.
Exactly. Paths where you gain more design authority, more technical leadership, without having to manage people if that's not your thing.
That's crucial for a lot of tech folks.
Definitely. And there was an interesting take on location, too, suggesting that maybe second or third tier cities could be better bets than the big saturated hubs like SF or New York.
Why is that? Less competition.
Potentially, yeah. The argument is that in some of those places, the demand for experienced talent might be higher relative to the local supply compared to the major centers where everyone flocks.
Interesting angle.
Well,
Worth considering. And, maybe unsurprisingly, work-life balance gets a strong mention.
absolutely. Presented as non-negotiable for long-term happiness and effectiveness. It's not a luxury, it's essential.
So, what should people look for in a company, according to this perspective?
It lists several things. Clear goals, they actually invest in doing things. Execution, a solid engineering focus, support for individual growth, decent pay, respect for senior non-managers, genuine respect for work-life balance, and work that's consistently interesting.
That's a pretty solid checklist for evaluating potential employers.
It is. And related to that, another article gets really tactical about the job search itself strategies, red flags.
Okay, let's get into the nitty-gritty of job hunting.
Well, first it acknowledges the reality. Online applications often have a really high rejection rate. It's tough out there.
The black hole of online portals.
Yeah.
Yep.
So it advises focusing your energy where it's most likely to pay off. Don't just shotgun resumes.
Be strategic. What kind of strategies?
Networking is key. Using your contacts for introductions, setting up informational interviews. The advice is specific. Reach out, mention the role you're interested in, ask for an intro to someone in the company, maybe not even the hiring manager initially, just to learn more before you apply formally.
Get the inside scoop. Makes sense. Do your homework.
Right. It also brings up a point we touched on earlier, the limited impact of just producing analytic reports if they don't get used.
The where analytic work goes to die idea.
Exactly that phrase. The real value, and often satisfaction, comes from seeing your analysis actually get productionized, integrated into how the business runs.
So look for places where analysis drives automation or decisions directly.
That's a strong indicator. And then, a huge warning. Avoid bad managers at all costs.
Easier said than done sometimes. What are the signs?
Things like constant flip-flopping on decisions, blaming others when things go wrong, dismissing concerns you raise, the classic toxic boss indicators.
Definitely red flags.
The article also has a nuanced take on teams. A great team can make a good situation amazing, but
It'd make a bad situation under a bad manager even worse.
exactly, it can amplify the dysfunction. But on the flip side, sometimes even a bad job, maybe one that's not ideal overall, can offer unexpected chances to learn specific skills you need.
Finding the silver lining. Being strategic about skill building, even in tough spots.
Right. Use the fear or anxiety of the job search constructively, but don't sell yourself short. Know your worth.
Okay, so what are some concrete red flags when you're interviewing or evaluating an opportunity?
Well, if you ask about work-life balance and they get defensive or give patronizing non-answers or just seem clueless, that's a big one.
How they respond tells you a lot.
Huge signal.
Mm-hmm.
Also, if the focus seems only on reports and dashboards with no clear talk about productionization.
Just churning out charts without impact.
Yeah. Another one is if they can't really discuss product management thinking versus just pure project management, like understanding the why behind the work, not just executing tasks.
A sign of strategic immaturity, perhaps?
Could be. Also, signs of what the author calls wimpy management managers who overvalue their own time compared to their teams, can't champion ideas they didn't think of themselves, or are overly accommodating to unreasonable demands.
Oof. Yeah, those are subtle but important signs.
And a lack of a clear process for prioritizing work beyond just the boss said so.
So no real strategy, just reacting.
It often points to chaos. Ultimately, the article advises using the smell test. Pay attention to your gut feeling. Do they seem uncomfortable or evasive when you ask about things that matter to you?
Trust your intuition during the process. Okay, let's shift to something different but equally important. Ethics.
Right. This is a challenging area, and one article takes a bit of a skeptical view on the effectiveness of formal ethical codes alone.
Skeptical. How so? Aren't codes of conduct important?
The argument isn't that ethics aren't important, but that relying solely on written codes might not be the best approach. It draws an analogy to competing technical standards. Having a standard doesn't guarantee good implementation or prevent misuse.
Okay, so a code is just words on paper unless it's lived and practiced.
Exactly. The author shares some personal anecdotes, times they were asked to, essentially fake results, or interpolate data in misleading ways, or torture data to fit a desired conclusion.
Wow. Real pressure to produce specific outcomes regardless of the data.
Yeah, and building systems with clear potential for misuse. The core argument is that ethical codes are neither necessary, good people act ethically without them, nor sufficient, bad actors ignore them.
And they might even be harmful. How could a code be harmful?
The idea is that codes can create fences. People might feel okay pushing right up against the boundary, doing things that are technically allowed by the code, but still ethically dubious or contributing to systemic risks, like p-value hacking in research, staying within the rules but undermining the scientific process.
The letter of the law versus the spirit of the law problem.
hmm
Interesting point. So if code's not the full answer, what are the alternatives?
The article suggests focusing effort elsewhere. One idea is developing better tooling to help identify unintended consequences, like bias in algorithms. It mentions tools like Equitas or tools to detect things like Simpson's paradox.
Using technology to help police the ethics of technology.
Kind of, yeah. Another idea is more localized, non-scalable regulation within teams or companies, like maybe internal systems for flagging ethical concerns about a project, simple things, maybe even color codes.
Empowering teams to raise flags internally.
Right. And leveraging reputation systems.
Hmm.
Not just general Glassdoor reviews, but maybe systems focused specifically on ethical practices within the data industry itself, though that's complex.
Building accountability through transparency and reputation.
That's the hope. The main point is that the profession needs to actively work on developing and implementing these kinds of practical alternatives, not just relying on writing another code of ethics.
Okay, a call for more practical, embedded ethical mechanisms.
Ah.
Now for our final topic, there was that piece on the role of social science. This seemed a bit provocative.
It was definitely thought-provoking. It asks why social sciences sometimes seem underrepresented or excluded from AI and data science education or teams.
And what's the argument presented?
The argument put forward is that AI, especially machine learning as it's often practiced now, is largely treated as an engineering problem. It involves a lot of tinkering, experimentation, incremental improvement,
Less about deep, upfront theorizing about human behavior.
more about building something that works, often through trial and error, rather than requiring a comprehensive social science understanding before you start. That's the perspective offered. It then critically examines the, quote, practical value and signal-to-noise ratio of tools from social science, maybe excluding ethnography, when judged purely by their ability to get concrete results in a business context, like changing user behavior or making money.
So questioning the direct applicability or measurable impact of some social science methods in a commercial data science setting.
That's the core of the critique presented in the article. The author even mentions personally downplaying their own background in anthropology professionally, despite feeling it helped them succeed.
That's quite revealing.
It is. The conclusion drawn in that piece isn't that understanding humans isn't important, but that maybe the social sciences, as currently practiced or validated in business, don't always provide the most direct or reliable toolkit compared to, say, computer science for solving specific data-driven business problems.
It's a pragmatic, maybe even harsh assessment based on perceived business impact.
Yes, it's definitely one specific viewpoint challenging common assumptions about necessary interdisciplinary inputs.
Okay, a lot to think about there. So just to wrap up our deep dive today, we've covered a ton. We looked at getting a much more nuanced handle on data science skills, beyond just buzzwords.
Right, thinking about those core competencies and the importance of the team.
We talked about the value of designing and streamlining workflows, not just for efficiency, but for clarity and better coding.
Making things explicit, uncovering assumptions.
We explored some really practical, maybe even unconventional career advice, thinking about sideways moves, widget making, location, and finding companies that value ICs.
And the crucial need for work-life balance.
Absolutely. Then we got into the weeds of job searching strategies, red flags, the importance of productionization, and avoiding bad managers.
Using that smell test.
Trusting your gut. We also tackled the complexities of ethics, questioning reliance on codes alone, and looking at alternatives like better tooling and local processes.
Moving towards more practical mechanisms.
And finally, that critical perspective on the role and perceived practical impact of social science tools within the current data industry landscape.
It's a wide range of perspectives we synthesized.
It really is. We hope this deep dive has given you, our listener, some valuable takeaways and maybe a clearer way to think about these different facets of data science, whatever your connection to the field is.
Yeah, hopefully some useful nuggets in there.
And maybe a final thought to leave you with. Data science is constantly changing, isn't it?
Absolutely. It's far from static.
So how will our understanding of these things, skills, workflows, ethics, the best way to build teams, the role of different disciplines, How will all that continue to evolve? Which of these ideas we discussed really hit home for you?
And how might they influence your next steps, whether it's learning a new skill, evaluating a job, or structuring a team?
Lots to mull over. These are definitely areas worth exploring further on your own. Thanks for joining us for this deep dive.